Have you heard about this kind of monsters that can eat anything? This is kind of unstructured. So this is the type of technology that makes me very excited. So unstructured allows you to import any type of data file and decode it into some format that can be easily digested to your LLM models, right? So that's what I want to show you today. So I'm working on this playground that is Unstructured pgai example, and my idea here is just to mix the technologies and show how to use them together. So what we have here is just we use the AI extension to create the embedding. So we have like an embedding function that gets some text and uses the OpenAI to convert it to a vector. And then we have this table named elements, and the elements contain this text that is like the content behind anything that it's getting. And you also have the embeddings that is generated using the text from the element itself. And this is generated always, so it generates in real time. And then we also transform these elements into a hypertable. Well, I still don't know where I'm going with this hypertable, but for now, as we have it available and we also have a column created at, probably I'm gonna to do a very large scale of unstructured files, so I can do it. And I already started doing something here, so I have two examples. One is fetching the data from the timescale page, and the other is importing any type of file locally. So let's start with importing anything. So Unstructured also contains like a command line application that Unstructured ingest, and this import sh is just configuring it to output it to Postgres. So it's an automatic process, so we don't need to do anything. What we do is we pipe to the elements table and we just convert it to hypertable. We change the defaults and it's just working fine without any changes behind the scene. And in the other example here, I have this fetch timescale page, which I just pipe some pages from the docs URL, and then we use this partition HTML, and partition is coming from unstructured partition HTML. So that's a function that you can use, and it will create these elements, and every element can have like this text and can contain this metadata about all the data, so you can get any type of data here. For example, you can see sent from, sent to. This is probably to match with mail, and then you can see link URLs, link texts, and everything, so you can just reuse this data later. So in this case, we are processing here docs.timescale.com, and then we also try to avoid to visit the same links, and then we keep recurring to process the pages when we find new pages, right? So that's how it works. I have it running here locally, and then you can see here it's already running for quite some time, so it inserts a few elements. And when you see here, I'm running in Docker Compose locally, and these inserts are already there. And I can show you that this database is here, and I can also search for things here. So select count star from elements where URL is docs.timescale.com, and we can see that we have a lot of pages here. If I get here, for example, select type and the text here, I already can see like the first one, the skip content, and then I have welcome to timescale, and I have all the data about timescale here, and then it goes for all types of fragments of data that we have, and it keep going. And what we can do here extra is that we can also use this further by clause using the embeddings. So the embeddings is already in the database, and this is where we are using the vector column to try to search for some semantic search. So our semantic searches are coming from this function here. So I have a function in my schema that is embedding, and this function is using OpenAI embed. So it gets a vector from the database, and then you can measure the distance of the vector locally. So you can see, say here, embeddings, and then you can say install on Linux, for example, and then let's see what URLs. Let's get the URL too, because that can be important. URL, not URLs. And embedding, not embeddings. Embedding, I just have a typo, sorry. And now we have all the links. So let me just reduce the size here so we can see the links are the red here, and then you can see the Linux one. So if we get the first one, let's just get here \x, and then we say limit 1, and let's get more details here, star. So here is the entire thing. So in the beginning here, we have the element ID, and then we have embeddings, and then we have the URL, when it was created. We can also see that we also have a link URL here that goes to installation Linux and so on. So this is the data that is coming for this element, and every element can fill some of these fields and also have some extra content. And you can also import some data. So for example, I have here locally running, for example, I have this PDF with embedded images, and I already imported this one. This is from the examples that the library comes. So if I say here, for example, let me just get where file name is something like embedded images, embedded PDF. Oh, I thought I have things here, embedded images. Oops, now I got some error, sorry, in my syntax, but yes, I have some record here, and I have this record, and this is saying categorize the text, and the text here is just saying 4. And this is one of the records. Maybe I count 1. Yeah, so I have a few things here. So let's get type and text here. So this is the data that is coming from this PDF file, and probably the Unstructured IO can also make the same with the images and do something else. And this is all doing it locally. So for example, this is talking about car, vehicle, and some vehicle behavior. So if I want to do some semantic search, I can also search by this, and this is also in the same database. And the cool part is that we can filter out by all the SQL logic, and we can also filter by semantic search. So mixing these two technologies is great, and Unstructured library is also great. So give a try and happy coding.